Ever wonder how services like Amazon Web Services or Google Cloud really work? You know how one single massive server can handle hundreds of different customers all at once? Well, the answer is a piece of foundational tech that, honestly, runs most of our digital world from behind the scenes, the virtual machine. So let's spend a few minutes and unlock exactly what that is and why it's one of the most important ideas in modern computing.
To really wrap our heads around this, let's just start with a simple question. What if one physical computer, one metal box sitting on a desk or in a server rack, could act like 5 or 10 or even 100 separate computers? It sounds like science fiction, right? But it's not. It's the very problem that led to the breakthrough we call virtualization.
And to really appreciate just how big a deal this solution was, we first have to understand the original problem. See, for most of computing history, the rules were, well, they were simple, but they were also really rigid. For decades, this was the law of the land. One piece of hardware could only run one operating system at a time. That was it. The hardware and the software were basically locked together. And sure, this worked, but it created some pretty serious headaches. I mean, just think about the real-world frustration here. Let's say you're a developer on a Windows machine, but you need to test your new app on Linux. You had two pretty terrible options. You could set up a dual boot, which meant you had to completely shut down and restart your computer every single time you wanted to switch. Or you could just go out and buy a whole second computer. Both options were slow, expensive, and a huge pain. And this exact problem was even worse in data centers, where every new service often meant buying a whole new physical server. So all this inefficiency was just screaming for a better way. And the solution that finally emerged didn't just bend the rules. It completely shattered that old one-to-one barrier. And that solution was virtualization. At its heart, virtualization is a really clever idea. It's about creating a virtual version of a computer using software. This software layer basically acts as a middleman, and it tricks an operating system into thinking it has its very own dedicated hardware, when in reality, it's just sharing the resources of a single, more powerful machine. And this is the most important part. Virtualization breaks that old rule. All of a sudden, one physical computer can host many different operating systems, and they can all run at the same time, totally independent of each other. This was an absolute game changer. So, the end product of this whole process is what we call a virtual machine, or just a VM. The best way to think about a VM is as a complete computer, but it's one made of software instead of silicon. It has its own CPU, its own memory, its own storage, all virtualized, and the whole thing just runs as a self-contained file on a host machine. You can turn it on, shut it down, copy it, or delete it, and it won't affect any of the other VMs or the physical computer it's running on. Okay, so how does this magic trick actually happen? What's the secret sauce, the software that lets one computer pretend to be many? Well, that brings us to the engine of virtualization, the hypervisor. It all comes down to a special piece of software called the hypervisor, sometimes called a virtual machine manager. Think of it like a traffic cop for the computer's hardware. It sits right between the physical machine and all the virtual ones, and its job is to manage all the real resources, the CPU, the RAM, the storage, and carefully hand out little slices of them to each VM that asks for them. Now, these hypervisors come in two main flavors. On the left, you have what's called a Type 1, or a bare metal hypervisor. This one gets installed directly onto the physical server hardware. It is the operating system. On the right, you have a Type 2, or hosted hypervisor. This one runs just like a regular app, like Word or your web browser, right on top of your existing OS, like Windows or Mac OS. And the difference really comes down to performance versus convenience. Type 1 is the heavyweight champion. It's what you'll find in data centers and the cloud because it's super efficient. Type 2, on the other hand, is perfect for a developer's desktop, when you just need to run another OS inside a window. It's way easier to set up, but you do take a bit of a performance hit because your main OS is also using up resources. Okay, so this tech is really cool, but here's where we get to why it truly matters to you and me. This isn't just some abstract idea. It's the engine that powers one of the biggest revolutions in modern technology, the cloud. It's really that simple. When you go to a service like Amazon EC2 or Google Compute Engine and you spin up a server, what you're really doing is renting a virtual machine that's running on one of their giant physical servers. VMs are the fundamental Lego-like building blocks of the entire cloud.
And using VMs allows cloud providers to achieve incredible economies of scale. Think about it. They can buy one enormously powerful server, put a Type 1 hypervisor on it, and then slice it up into dozens of smaller VMs to sell to all sorts of different customers. Adding a new customer doesn't mean buying a whole new server. It just means clicking a button to create a new VM. And these benefits create a massive shift in how businesses even think about technology. Instead of spending a ton of money upfront to buy their own servers, companies can now just pay as they go for exactly what they need. That flexibility and affordability gets passed on to everyone. It's why a small startup can rent a powerful server for just a few bucks an hour instead of having to buy one for thousands of dollars. It's a complete business revolution, all powered by virtualization. So for our final section, let's just quickly peek inside one of these virtual machines and see what makes it tick. I mean, what does a computer made of software really look like under the hood? Well, just like a physical computer, a VM has all the core parts you'd expect. It's got a virtual CPU or vCPU, virtual RAM, a virtual hard drive, even a virtual network card. To the operating system running inside that VM, these look, feel, and act exactly like real hardware. But in reality, they're all just clever software constructs being managed and handed out by the hypervisor from the physical machine's real pool of resources. So there you have it. Virtualization is the technology that broke the physical barriers of computing. It completely changed how we build data centers and really how the modern internet itself runs. And it leaves us with a pretty fascinating question to chew on. If our computers can already run virtual computers inside of them, what comes next?